Morning or evening or afternoon or whatever. Good morning, regardless. Um, this video is going to be a recording of what was gone over in class October 12th and October 13th. That's Monday and Tuesday of week 9. So to start off with, last week's materials have been put into a week 8 folder, and the previous materials, week 1 through 7, have been put into unit 1 folder. Expect next week for the week 8 materials to be put into the unit 1 folder like normal. And let's get started into our agenda. Overall, this past weekend, the 10-week report cards should have been sent out. And overall, I was pretty satisfied with where grades are at. But I would like to take this opportunity to remind you that I don't really have late penalties. If you have work that you need to turn in, please do so, right? If you reach out to me in class or email or Schoology or Remind, I'll update your grade and I'll most likely waive any late penalty even after the unit is over. Just you gotta take that first step and reach out to me. This week, we're gonna start to wrap up our unit. We only have 3 more topics to cover: changes in matter, intensive and extensive properties, and mixtures. After those 3 are done, we're headed over to the unit assessment and then new unit time. So as I'm recording it right now, if you're watching this, this is a class recording posted onto YouTube, and other recordings will be available later on. Do note that the evidence notebook we're working out of will be graded at the end of the unit, and if you have to catch up on that, just check the Schoology notebook. This week, like I said, we're going to be working on assignment 5, changes in matter, and Friday is an odd professional development day, so if you're in even class, I'm not seeing you, and if you're in odd class, it's a shorter period, right? No assignments are due this week, so use the time wisely to catch up on older assignments or redo older assignments for a better grade, right? If you got a 2 out of 5, you could easily raise that up to a 5 out of 5. A 4 out of 5, raise it up to a 5 out of 5. Okay, a couple things just to note. 2 weeks ago, we did quiz 1, unit 1, quiz 1. There are 3 attempts on that. If those attempts didn't pan out the way you want, if you didn't like it, you could go ahead and take quiz 1, version 2, right? Unlimited attempts, but you gotta take it on your own time. We did it once in class, you're gonna have to do it again on your own. Okay, so if you don't know already, the evidence notebook is always on Schoology. It is the 3rd link. If we click it, we'll get to this page. You should have made your own copy of it. Right, to do that, you will go to File, make a copy. As long as you're signed into Google, you should be able to do that just fine. Now, what we're going to do is we're going to go ahead and click on assignment number 5, click on the doc. We're just going to copy and paste this entire thing. I make sure you highlight it all, copy it, and then paste it into the bottom of our evidence notebook. And so that's what we're doing today. We're working on assignment 5. For previous notes, they're still filled in. They're out there. You just have to check them. If you want to fill them out, honestly, just copy and paste it into your own notebook so that you have it, right? At some point, I'm going to be withdrawing the permissions. So you're going to have your own notebook. All right. So last week we were talking about chemical and physical changes. We're continuing off of that. For this assignment, we're working with learning target number 3. And here's the rubric. If you don't do it, if you just have it or don't have it, you're going to get a 1. It's not yet done. If we follow along with today's lesson, we're going to finish the data section, and you'll be at a 2 out of 5. If we finish off with the next section, the analysis section, which we'll cover on Wednesday and Thursday, you'll be at a 3 out of 5. So already you're at a C. The last 4 questions are the conclusions, and that's for you to do. That will push you up into the proficient or mastery range. Now, there are 2 other links, one that describes a physical change and one that describes a chemical change. Let's go ahead and look at these. Physical changes are changes that do not change the identity of the object. So if you rip some paper, at the end of the day, it's still paper. If you melt some ice, if you change the state of matter for ice into liquid water, it's still water, right? There's no chemical change. For a chemical change, it does change the identity. It also changes the physical form. So with sugar, if you ferment it, it becomes alcohol. Notice the color change, notice the state of matter change, and chemically speaking, it does also change. With the log, it's a lot easier. You burn a log, it turns to smoke and ash, right? That's a solid and a gas. So that's a physical change there. Most wood is carbon. You burn carbon, it becomes CO2, right? It's a different chemical now. And so that's what we're looking at. We're looking at whether or not something is a chemical change or a physical change. To do this, we're going to first have to establish what properties you start off with. And so for our first three substances, we have chalk turning into crushed chalk. We have chalk and water, right? Mixing the two. And you have chalk and vinegar. We could just go ahead and write the physical properties of this stuff down. For the most part, we were saying that chalk is powdery, it's white, it's a solid, it's dry. That's pretty good. We're gonna go ahead and write that description down for everything that is chalk related. For the next part, we're looking at water. What is water? Water is a liquid, it's clear, it's tasteless, odorless. That's pretty good. Let's look at vinegar. Vinegar, if you drink it, it's acidic. It kind of burns going down. It's definitely a liquid. It's a bit sour tasting. Does it smell weird? It smells pretty bad, right? It does have odor. And so that's what we're doing right now. We just describe our physical properties. And to describe a physical property, all you're doing is using your five senses, sight, smell, taste, hearing, touch. You describe an object with your five senses. Now, what we're going to do is we're going to watch several videos, and then we're going to just see what changes occur. Let's go ahead and click on the first video. I'm going to mute the sound so I don't get dinged based on YouTube's algorithms. So we have chalk, right? This person's going to take the chalk and just crush it. You would hear a lot of cracking noises about that. And you could see his finger has a little paste on it, right? It's got a little bit of that paste on it, but it's mostly just crushed. Let's just keep that going. Cross that out. And so for physical properties, after it's crushed, what can we say about the chalk? Well, it's even more powdery. But at the end of the day, it's still white, still solid, still dry. And so is this a physical change or a chemical change? This is a physical change, right? There is no change in identity, right? And so that's how we know it's a physical change. At the end of the day, the chalk is still the chalk. Go ahead and click the next one, mixing chalk and water together. This is a relatively interesting one. If you watch it on your own, be aware that the music is rather loud. And the title of it kind of gives it away. It's a chemical reaction. But let's take a look. You have the chalk and the bubbles, and then boom, they drop. Why is that? We're seeing this, right? There's a lot of bubbles coming out of here. But this chalk is also a fairly good piece of chalk. And so for the most part, it's going to be hard to see because you don't have this in front of you. But if I were to take out the chalk, you would see that it's not quite as powdery anymore. The chalk itself is a bit slick. It's still white, still a solid, not quite dry anymore. The water is still water, so we're not going to just add that in there. Well, the biggest thing that you should have seen are the bubbles, right? The bubbles are coming out, and what's happening there is that the water is reacting with our chalk. And so this here is a chemical reaction, and if it's a chemical reaction, it's also physical. And so if that's the case, how do we know it's a chemical reaction? Well, first of all, gas was produced. From our notes, we should remember that one sign of a chemical change is the production of gases. Another sign is an output of energy or a change in color. And so these are our signs for a chemical change. We know a physical change occurred because we have a state of matter change, right? You had a solid that turned into a gas. And that's a pretty important thing to note. Now that tells us it's a physical change. The next one, it's going to be a little bit more reactive because if you have vinegar, I'll let you watch this right now. Grab a bit. We have our person here pouring in the vinegar. Just as a side note, most of the time vinegar should not have bubbles in it. The force he's putting the vinegar into is going to be creating those bubbles. Let's take a look. He's going to grab some chalk, break it off. Snap it in, put it in, and we have 3 pieces, and in like 5 seconds, one already drops. Next one. Let's see if we get a drop. There we go, both of it. Look how many bubbles came out. A lot. And if we were to look at it even further, this chalk isn't very high quality. It's got a lot of coloring agents in it. It's got a lot of binding in it. And even still, even with all of that, the vinegar is eating away at it, is reacting really, really well. And so what we're going to do is the change that we see is identical almost to water. But the big difference here is that the bubbles are coming out faster, right? The rate is faster because our vinegar is far more reactive than water. It's way more acidic, and so it eats away at the carbonate inside of our chalk. Okay, so we've got 4 more videos. I'm gonna speed this up because, you know, attention spans and all that. So we have silver nitrate and sodium iodide. Silver nitrate is a chemical used for photography. Sodium iodide, it's a health supplement. And so most of the time they're used in chemistry classes because they're really good at something we call forming precipitates. And so here we have silver nitrate being poured into a test tube. And so how would we describe this? With our 5 senses, we can see that it's a liquid. It's at least a solution. You see that it's clear. What else can we really say? It's probably odorless. So let's stick with that. Sodium iodide, also liquid, also clear, also odorless. So let's see what happens when these two mix. Here we're going to have very soon sodium iodide up on the screen. We have 1 molar Na, but sodium, iodide. And he's going to pour it in. You can kind of see it off to the side when it drips down. It's very clear. But as soon as it hits our silver nitrate at the bottom, you start to see a precipitate form. When that precipitate forms, you can start making our observations. And so what do we see? It's no longer a liquid. What I will tell you now is that we have something white, right? We have a white, and it's called a precipitate. Precipitate. And that's basically a solid. If I took a coffee filter straight through it, I could pick up all this white stuff and I'd be able to dry it out, and it would be a solid. And so that's my biggest change here. Everything else basically stays the same. There's still liquid in there. Some of it is still clear, but that's the biggest change. And so for a chemical, for our type of change, it's very clearly a chemical reaction going on. But like I said, all chemical reactions, all chemical changes have a physical change attached to them. And so for our chemical change, we know it's a chemical change because of the color, right? It went from clear to white. For the state of matter, we had a liquid turn to a solid. And so these are our options here. Let's take a look at option 2. Right, silver nitrate, sodium hydroxide. We're just going to go ahead and copy and paste this over to there. And so our liquid solution is still clear, is still odorless, and we're going to mix it with sodium hydroxide. Sodium hydroxide is commonly known as lye, and that's one of the components you have in soap. It's a very strong substance, and when mixed with sodium, when mixed with silver nitrate, we're going to see this reaction. And so our observations, whatever observations you see, put it in to your chart. As far as what I could see, we have a coffee colored precipitate form, and the volume of this expands relatively quickly, right? So we had like this much, and as soon as we kept putting it in, I know we're putting in more liquids, but the volume of this is expanding relatively quickly. Again, we know it's a chemical change. We know it's a physical change as well because it's a chemical change. We know it's both. Again, we know it's a chemical change, mostly based off the color. Right? It turned from clear to coffee. And the state of matter, again, changed from a liquid to a solid. So again, you could take out all of this goop, right? All of this as a chunk with a thin enough piece of filter paper, right? If you have some coffee filters, you could run it through and extract all of this. And that's what makes it a solid. That's how you know it's a solid, because you can extract it relatively easily. You can even take a magnet to it and probably try to get it out that way. So we have 2 more to go. We're wrapping this up relatively quickly. So we have lead, nitrate, and sodium iodide. I'm not going to describe it just yet. I'm going to have this guy pour it out. We have lead nitrate. Okay, so on my screen, this back end of the crystals kind of looks yellowish. The white end kind of looks white. And so for lead nitrate, we could say that it's a white, yellow crystal. Kind of like sugar, if you've ever seen pure sugar like that. Right? Next up, we're going to pour out the sodium iodide. We're going to see the differences there. And so that is much finer, right? It's really, really well grounded. And so first of all, these are both solids. They're going to turn into liquids later, but for now, they're both solids. And the other one is this pure white, really fine grained. And it's also a solid, right? Kind of like, not like sugar, like kind of like flour. And so what we're going to do now is we're going to put these in solution. And now what I mean by that is we're going to pour equal amounts of water into both. And mix it up, right? Give it some time, mix it, mix it, mix it. It's a bit hard to mix lead nitrate. You're going to see that's kind of cloudy looking. The sodium iodide dissolves a lot better. We're going to combine. So notice the sodium iodide goes in, nothing happens. When the lead nitrate hits it, that's when you see this bright color change. Probably one of my favorite reactions. So what do we see happening? You see a yellow precipitate formed. Again, if I took a fine strainer, if I took a filter and I strained my solution here, that's a solid, right? I could take it out, make it into a paste, and that's a solid. And if you were to touch it, it would feel pretty gritty. And so we have, again, chemical reactions taking place, and it's also a physical reaction, right? There are physical changes and chemical changes occurring. How do we know it's a chemical change? Well, we got a color change. Clear to yellow, a bright yellow. The state of the matter, again, changed from a liquid, that's what it was in beforehand, to a solid, okay? And so that's what we're doing. We're just determining how they are changing. What evidence do we have that they changed? Fun fact about lead nitrate and these paints that we're making, if you were to do this, actually not even if, previously in the 50s, people used to love lead paints because they had such vibrant colors. And so these are very common in house sidings, right? Like the sides of a house, cribs. And so they are very common because it's just so bright. Nowadays, we know that they degrade your brain, and so we stop using them, but for the longest time, use them all the time. All right, for this one, we're talking about copper chloride and aluminum foil. I paused it. Let's go ahead and just write down what we know about aluminum foil. It's silvery, it's flexible, solid, the metal. What else do we know about aluminum foil? It's thin. That's pretty solid. Let's see what they're doing. They take water, measure it out. They got about 100 grams. You put copper chloride in there. Copper chloride is very poisonous. Do not eat. It's very pretty though. So mix it in, let it soak for a bit. Really get those crystals all nice and melted, nice and dissolved. Great. Now mix it up. And we get something very close to what the color of Windex is, right? A bright neon blue. Let's go ahead and write our descriptions down. The copper chloride, it is a bright blue liquid, right? We saw that earlier, that is poisonous. It was on the label of that jar. And that should be it. We got the color, we got the state it's in, we got some other facts about it. Probably doesn't taste very good. Oh, and let's see what temperature we're at. About 22 degrees Celsius. Okay. Next up, you're going to take some foil, measure it out, throw it in there. And look at what's happening here at the bottom. We see a lot of bubbling. It looks rusted, right? Very brownish red color. Keep it going. You see a lot of steam coming up on the top of the beaker. And the color of this is very green now. Let's take a look at the energy. We've got 54 Celsius almost. So let's take a look at what changed. 54 degrees Celsius. The aluminum basically rusted. What else? The blue-green, the solution color is now like dark green. And so we've got a lot of things going on here. But we pretty much hit most of it. The solution changes color, the aluminum rusts and breaks apart. The solution is, yeah, different colors. And so we know that there's a chemical change here. And there's also a physical change. So let's take a look. What are our signs for a chemical change? Well, we have the color change, right? From silver to, I guess, brown. You also have the blue to dark green. That's one sign. We have an energy change, right? Output of energy. It went from 22 Celsius to about 54 Celsius. That's pretty huge. And lastly, how is it a physical change. How do we have a physical change coming here? Well, you saw what happened to the water, right? The state of matter changed. The water was liquid and it became steam, right? A lot of steam came off of this. What else gave it away? The how do you say, the aluminum broke down, right? If the aluminum stayed in one piece, that would be fine, but the aluminum broke down and possibly even turned into a gas. I'm not going to write that down, but because that's a possibility, we're not too sure. Uh, so we're just going to stick with this. And so that's it. Well, that's all we did on Monday/Tuesday. On Tuesday, we didn't really get to cover lead nitrate and copper chloride. So I covered it in this video right now. So I hope you were able to follow along, pause as necessary, turn on those captions, and don't forget that I have all of our notes up on these, up on the evidence notebook on Schoology. I hope this video serves you well. I'll see you in class. Have a good rest of your day. Bye-bye.